All right, Jack Clark, who wears a lot of hats, but for the purposes of this conversation is co-director of the AI Index Steering Committee. Welcome to the Data Exchange Podcast.
Thanks for having me, Ben. I'm excited to be here.
All right,
what should we talk about?
This is one of my this is one of my favorite annual reports. And for our listeners who are not familiar with this report, let's set some context first. So, for the purposes of this report, what is AI?
AI is basically machine learning, and mostly in these reports, deep learning, because getting data about forms of symbolic AI or expert systems is actually very, very challenging. So these reports kind of track and analyze how modern machine learning systems are being developed, how they're doing technically, how they're being funded, and aspects of the community that build them, like who students are, where students are going, that kind of thing.
Which, So which brings me to my next question, which is basically the key metrics in the report you alluded to. So there's the benchmarks, there's publications, there's patents, there's legislation or regulation, and then industrial metrics like VC investments. I had not heard about the student thing, but so does that cover kind of the metrics that you guys are tracking on a year?
Yep, that covers it pretty well. And every year we're basically trying to further flesh out the metrics we are tracking and find new ones that we can add into the report.
So for our listeners who don't follow benchmarks that closely in ML, how important are they to the researchers?
It's a good question. A paper came out recently that analyzed 1,600 benchmarks that have been developed for AI in the last few years. And it found that 33% of those benchmarks had 3 or fewer data points, as in 3 or fewer times they'd actually been used and tested. So we should set the level that 33% of benchmarks are useless, right? Maybe 66% have more than three sort of data points on them. Some benchmarks, though, do actually matter. Like there's a famous one called ImageNet, which is how well you can do at classifying images. And ImageNet is a genuine proxy for how good general computer vision systems are getting. And it's the sort of benchmark that researchers actively compete with each other on. So if you're measuring ImageNet, you're getting a really good sense of the state of progress in image recognition. Similarly, there's a benchmark called SuperGLUE that tracks natural language processing, and that similarly is competitive enough that you get a big signal off of it. So to answer your question, some benchmarks matter a huge amount to researchers, some are completely meaningless, and the AI index tries to include the ones that matter.
And then one of the things that readers of the report will glean is that benchmarks also kind of come and go in some ways, right? So benchmarks get too easy in some ways, right?
Yeah. And a phenomenon we've seen in recent years is we are solving benchmarks faster than we are creating them, which is actually a problem. Like systems are coming out, they are suddenly climbing really high up the metric being sort of evaluated, and there isn't a harder or different benchmark to then test the systems on. So for some parts of AI progress, we're now kind of flying blind because the systems have started flying and we don't have systems to let us see sort of better evaluate and test their capabilities.
By the way, in some areas it's just hard to create benchmarks because there's no consensus of how to measure things. So the example I have in mind is text summarization. So what is a good summary?
Yeah, summarization is an illustration of how we're starting to be able to do sufficiently advanced things, but the benchmarks are not really going to be as quantitative. They're going to be qualitative. They're going to be how different humans interpret the thing as being useful. And so that's a challenge. Very hard to build benchmarks around subjective human qualitative impressions of the system. Another area where it's challenging is robotics, right? If I have one robot in one lab and a different robot in another lab, even if I'm testing on the same task, there will be massive variations in just the physicality of these two different robots, and actually figuring out how to evaluate them together is also challenging.
And then the other thing that the people who don't follow this space closely will notice is that each of the areas actually have quite detailed benchmarks. So take an area like computer vision.
Yep.
It's surprising the number of different tasks that are used by researchers, but they tend to be, and you can push back on this, Jack, if you want, but in my mind, they tend to be kind of very small tasks. Is that the right?
Yeah, there are lots of computer vision evals which are, well, small might be the wrong word, but a correct term might be like
very targeted.
Very targeted, and also some of these correlate nicely to real world deployment, but some don't. You know, like I'd argue that there are image data sets called CFAR 10 and CFAR 100. Computer vision researchers use them. They use them to they assess their progress relative to their ability to do CFAR tasks. But these data sets are not like actually that useful. They're just sort of proxies for a certain type of progress. And other data sets in sort of computer vision can be a lot more legitimate, but those are mostly used by very, very, very large companies because they're really, really intensive benchmarks to run as well.
So the one of the historically famous, it's not a benchmark, but competitions in AI is this kind of DARPA self-driving car out in the desert thing. So are there now, Jack, does the report go into more complex competitions like that?
We're looking for them, but there actually aren't that many. The DARPA self-driving car challenge is kind of like the exception that proves the rule. I wish that there were more what I'd call like ecologically salient benchmarks like this. And what I mean by ecologically salient is you can't really fake being able to self-drive your car around like a real-world desert or obstacle course. It's very hard to like game that. So it's a very trustworthy thing, but there are very few of those. A thing which I think you can expect to see soon is now we have AI systems that can do a lot of natural language processing and generation. We're definitely going to see people evaluate these systems in multi-turn conversation with humans. And so you can imagine really weird competitions that are going to get set up, like debate societies and other things, which will be an exciting way to like show progress in this area, but we're not quite there yet.
So this would be similar to the text summarization in that it'll be like a focus group, qualitative kind of eval metric.
Yeah, an eval metric I like is getting AI systems to generate short stories, and then I read them to my really young cousins, and I see if the stories generated by the AI can amuse a 6-year-old. But that feels actually to me like a good test, because parents make up stories for their kids all the time, and if an AI system can make a kid laugh, you're like, oh, well, I think this is a relevant story that it's generating, you know.
So what do AI? So what about in robotics? Didn't they have like a competition around soccer?
Oh yeah, RoboCup.
Yeah.
That includes the real RoboCup, where you see the little robots try and kick balls and fall over a lot. Yeah.
Right. That, and then a bunch of different research groups started getting into multiplayer games. Is that not interesting to have different groups compete in a tournament?
Yeah, it's interesting, but I don't think it's the only way to do it. Like you know, a way to think about this is multiplayer competitions are kind of interesting, but you could also train models to just simulate multiple different players and player personalities. That's what DeepMind did for StarCraft, right? It had a model spitting out lots of slight variations of a StarCraft player and played in a virtual league against itself until it sort of refined all of its own strategies.
And this is generally a problem, isn't it? In terms of when you know what you're trying to optimize for, then you heavily optimize for that, but that doesn't mean you can do other things.
Yeah, I mean, there's some of this in the AI index where when we started, because we're now in our 5th year, when we started, we're really focused on tracking basically performance of reinforcement learning systems on things like Atari games, Pong, Space Invaders, all of that stuff. These days, you'll notice that a lot more of the sort of action is on these big text generation and text classification models, so-called large language models and code models. And there's actually a really good reason for this. Years ago, many researchers trying to build, really general and intelligent systems thought the answer was training on an ever-increasing distribution of games that you ran in a reinforcement learning sort of mode, and you'd get a general system at the end that could do almost anything. Now, that hasn't happened at all. We just have powerful reinforcement learning systems, but they're not exactly deployed or, being used in the world. In recent years, we have this other research idea, which was maybe you should just train a model on like a percentage of all the text people have written on the internet and just try and get the model to predict the next word in a sentence. And in doing so, that yielded systems like GPT-2, GPT-3, Lambda, Gopher from DeepMind, that have actually proved to be general. Like we now have general AI systems, but they didn't come along from the format we expected. And that's why with the index, we're trying to sort of track everything, because that neatly illustrates how if we just tracked reinforcement learning, we'd completely miss this. And if we just tracked like tech stuff, we'd probably miss whatever the next big thing's going to be. Yeah.
By the way, I'm already kind of using two concrete products from these large language models. The first is AI21's kind of assistant. And as listeners may not know, Yoav Shoham, who's one of the co-founders, one of the original founders of this index, right?
Yeah, he's on the steering
and then
committee.
The second one is, I'm kind of blown away by how good the coding assistant is.
Copilot
is part of GitHub. Yeah, Copilot. Yeah. I mean, you're just typing there and you're just going, my God, this thing is suggesting things that really make a lot of freaking sense.
Yeah, it's weird, right? Like 5 years ago, a code model or a language model, you were lucky if it generated one line that was coherent in a sea of incoherence. Right. And now you're able to give these things code snippets and it predicts not only like a sensible idea, but the code runs.
I think I would imagine in 5 years, all I have to do is basically spec out what I want.
Yeah, I think that's true. I think that humans are going to be basically saying like a design document to a computer, and then they'll go away. A load of models will then kick in. There'll be a big code model. There'll be a classifier model. There'll be a rejection sampling model. There'll be all kinds of these things. But after you've given it the design document, it'll just spit out an entire program back at you. You're
then free to tweak it, improve it, learn from it.
Yeah. Right? Or ask your own other AI model to tweak it and make some variations for you. Like there are going to be wildly impressive feats of sort of coding automation and generation in the next few years. And I think it's going to change big swaths of like how the tech industry works. I'm always wary with AI about making like big proclamations, but I think the thing here is like coding's really valuable. Coding's also like difficult.
And we don't have enough coders.
We don't have enough coders, and we have AI models that, as you said, can come up with like a sensible suggestion.
Sometimes surprisingly so, because basically, wait a minute, I haven't even touched on this part of the program, and you already know what I'm thinking, right?
Yeah, but it's think of it this way. Occasionally, Facebook will advertise a really relevant product to me. And I'll be like, how the hell do you know that I wanted that? And it's because it's made some prediction about me due to a load of things I've done on Facebook. And I think these code models are similar. You may not even realize parts of the problem you're trying to solve, but they'll be like, oh, this looks like this sort of problem. I've solved these all the time, and then do a solution which includes things that you maybe hadn't thought about. That's the amazing part. Yeah.
So I'd like a co-pilot that's only trained on Jeff Dean and Sanjay Gemawat's source code.
That'd be pretty good. Yeah,
Yeah,
I
yeah,
think
yeah.
the ultimate overpowered co-pilot. Maybe we can just fine-tune co-pilot on Jeff Dean at some point and see what happens.
So going back to the index, you alluded earlier. So it's mainly deep learning.
Yeah.
And then we talked about the metrics. So to what extent does the index start thinking about, okay, so here's certain benchmarks, but what about the needs of people in industry? So which ones of these models can be productionized and or practical, maybe too large or too complicated? Do you guys think about that in the index?
We do sometimes. We do track the TREC test, which is sort of a knowledge retrieval task, and that shows up certain systems that don't use deep learning. Actually, winning systems that TREC frequently use a mixture of techniques, including more of the sort of expert system stuff. And we know that TREC is a highly relevant benchmark to industry, and like information retrieval is just a well-established, economically valuable thing. We do try and guess at it. The other benchmarks we use that I think are most relevant to people from industry are the things which focus on sort of the hard computer vision things like ImageNet, the hard dialogue things like VoxCeleb, the hard like NLP things like Superglue. Basically, for any domain, there's a really big gnarly, there's usually at least one big gnarly test that actually is sufficiently hard that it correlates to real world utility. And then there are a load of like much more specific tests, which are probably more of interest to practitioners in that domain or researchers.
So one of the things that I've noticed that people want to do, and I think it makes a lot of sense, is this so-called end-to-end model. So, for example, in speech, you may have different models for the acoustic side, the natural language understanding side, and so on and so forth. And then people want to do, can we do one big deep learning model to do end-to-end the speech recognition, right? So are some of these end-to-end models showing up as winning some of these benchmarks?
Yeah, like Superglue in recent years has been won by a series of end-to-end models like T5, GPT-3, Gopher, Ernie from Baidu. So that's been the case there. For computer vision, we are seeing the emergence of just one really big vision model. That's been responsible for a lot of what's driving progress on ImageNet. For reinforcement learning, similarly, we're starting to see like systems show up where they've just been trained on a wide distribution of environments and one big model kind of wins. I think the way I think about this is having loads of models working together frequently gets you a slightly better solution than just having one big model. But architecting the way all of those models work together is actually really challenging. But instead, if you just train one big model, you might get for free within it an architecture which has different aspects of the model. It's just contained within a single model that's figured out how to do that for you, rather than you, the human, having to staple a load of things together.
And I think that's the key point there is the motivation is really kind of the deployment and practicality of these things. Interesting.
Well, it's not just that. But like I think it's worth stressing that at really large scale, models seem to display these emergent capabilities which are very, very subtle and which are hard to actually program in yourself as a human. So this phenomenon we're getting now is these really big models give you a lot of the stuff that you used to have to build a specialized system for. They just do it kind of innately as a consequence of the training process, which is actually crazy. I wouldn't have thought 5 years ago we'd have models of this level of generality in so many different aspects of AI, but we've started to get them.
So the resurgence in deep learning, you can trace back. A lot of people think about computer vision, but actually speech, it may have actually even started out earlier in speech technologies, right?
It did.
So what's going on in speech these days?
Well, in speech these days, you see frequently the best speech models now are from a small set of private sector companies, and that's because they have vast amounts of data. You know, Siri, the Google Assistant, all of these things, Alexa. And what you're seeing happen in speech is really, really large data sets getting used to train sort of big speech models. But a problem with speech is human speech varies massively. So those speeches got way better. You probably, you know, you have a bit of an accent. I bet you've noticed that your systems sometimes totally fail for you. They fail for me because I have like a half English, half American accent. And so I know I'm on the edge of some distribution sometimes. And I hear that as the system like fails. So speech is like an area that's had vast amounts of investment, but counterintuitively, it's not going to feel as good as some of these other AI modalities for a while, because I think the variation in how humans speak is so vast that it'll take us a while to get there. And actually, one thing you're seeing is like
And it's
synthetic
also
data generation and stuff.
the natural language understanding component of speech is immensely more challenging, given that we tend to not produce perfect sentences right off the bat.
Yeah, it's an interesting question of language models are starting to be used to improve speech recognition systems, because they can kind of, the speech recognition system will do a transcription that's obviously wrong, and the language model can like figure out how to fix it. But it raises this interesting philosophical question, which is, as you say, people talk differently to how they write. So language models are trained on stuff people have written, not stuff that people have said necessarily. And when people talk, they talk in a less coherent way than when they write. So it'll be interesting to see if we need to build a data set of incoherent human speech to train a really, really good classifier.
So if you look at the benchmark overall, the report overall, so and this is going to be a hard to answer, but to what percentage is it dominated by industry versus academia? And then industry here for me is basically means a few big companies.
Yeah, I'd say the frontier, both in research and in commercial sort of activity, is dominated by a small set of private industry actors, and there are good reasons for this. Like a lot of them
that are all around here in the Bay.
Yeah, that are all around here in the Bay, plus Chinese companies. A thing that we do track in the index is, you know, just as Facebook, Google, and Microsoft have stood up really large AI research teams, started deploying stuff, and contributed both in research and commercial settings, the same is true for Alibaba and Baidu and Huawei. And it's important to remember that AI was dominated for many years by a small set of US-based or Western actors, but actually in recent years, and this is stuff that shows up in the index in a bunch of places, China has emerged as this really significant power center in AI, and it's actually ranks consistently above Europe on pretty much any metric that you care to use. So it's like the US and China are the two kind of poles of the AI community right now. One thing to note, though, is that
I chaired an AI conference in China for 4 years, and it was it was I was always impressed by the amount of interest and just hunger.
Oh yeah, when the AI index comes out, I guarantee you there will be at least one article which focuses on the technical performance section in great detail, and it will be from a Chinese publication. We actually see Chinese publications show up and cover much more technical aspects of research than Western ones. And I think that this correlates to some of the enthusiasm over there. Just one note, though, is in the West, research and deployment is dominated by private sector actors. This isn't true in China. In China, they've actually done a better job of having places like Tsinghua University and other major universities are also doing big model development and big model deployment. And that's different. We don't actually see that in the US. In the US and Western Europe, it's about private companies. But in China,
made in China,
a bit better.
Made in China, whatever initiative Xi Jinping has.
2025, yeah. So GPT-4 made in China 2025 or something. Yeah.
So for a while, the barrier for the academic groups has been lack of compute, lack of data.
Yeah.
And then basically, I think also to some extent, and when I talk to my professor friends, there's also the challenge of retaining grad students these days because there's just so much more incentive to go to industry.
Yeah. I think those are all correct, but there's one additional problem, which is that it's really hard for universities to hire and pay engineers well.
Yeah, exactly.
If
That's the other thing.
if I wave my magic wand and I give an academic a load of data and a load of compute and even some grad students, they're still going to have trouble because they don't have dedicated like research
Systems,
engineers to
distributed systems kind of people.
Yeah, exactly. Like these models now, at I work for my day job, I work at Anthropic, an AI research company that I co-founded. And one of the really big challenges we have there is running a really large distributed systems cluster. Doing machine learning jobs on hundreds or thousands of GPUs, babysitting them, making sure that they don't break, waking up in the middle of the night when they do break, all of that stuff has to happen. And it's something which academia isn't very well placed to do. And I think that this is actually, one of the reasons why people go to industry is because industry has the big models. One of the reasons why you can't build big models in academia is because people go to industry. So there's a fun paradox here. Like many of the things pulling people out of academia could be built in academia, but the incentive structures are really poor to build them there. And it's sort of a challenge that we need to think about, or else all AI stuff is just going to migrate into private companies, which is probably bad overall for, democracy and various things like that.
So I'll give a shout out to Ray, and full disclosure, I'm an advisor to Anyscale, but Ray is really kind of made it simpler to do a lot of these things, especially with their new library called Ray Train, which I think
that's Jan Stoiker's
startup.
Right?
You guys should check them out, and we can talk after. Maybe I can broker some introductions. But so for example, for me, I'm on my laptop, I'm building something on my laptop, and I add a few lines of code, and boom, I'm on a cluster. But everything I do on my laptop translates. So I'm Visual Studio Code on my laptop, add a few lines of code, boom, it's running on a massive cluster.
Excellent. I think this like click to deploy thing is going to start getting more real. So there will be systems like this that make it easier. A question that you might want to think about is like, how many workloads are going to fit what you just described versus how many are going to require their own like custom tooling? And my suspicion is the massive frontier, like Microsoft trained a text model called Megatron Turing that was 600 billion parameters trained on something like 3,200 GPUs. I think that stuff will always require custom work. It's just going to be a moving target.
They have Ant Group is using Ray for massive cluster. I forget how many cores.
Oh wow! Okay, well then maybe I'm miscalibrating. Ray's actually gonna climb up there.
Yeah. I mean, I'll tell you something more. I can't tell publicly off the record after this podcast. But so you were involved in this aspects of this report, and for listeners who haven't seen the report, the reason I emphasize that is there's no way Jack could have written this report. It's 158 pages by himself. So there's certain aspects of the report you were more deeply involved than others. So give us your favorite sections of the report.
I'll state, obviously, there's my co-chair, Ray Perot, there's the whole steering committee. We have an excellent staff on the report at Stanford. Daniel Zhang and Nestor are two of the people who you probably won't hear about on like a podcast, but they are the ones who do a huge amount of work on this. And also this year, we worked with external people, including Helen No, to do a dedicated chapter on AI ethics. And so that's what I want to shout out, is that this year, the report has a chapter on AI ethics. Before, we've tried to cover that within technical performance, and it's always been challenging. As you know, ethics is qualitative. This is a quantitative report, so figuring out how to get it in has been difficult. But this year we did. And what we did specifically is focused a huge amount of attention on all the work that's happened on language models in recent years, where there's been tons of AI ethics analysis of them. So interesting findings this year include, as the capabilities of language model scales, so too do their toxicity. Basically, their ability to generate insulting text improves as they get generally better at generating text, which makes sense. But it illustrates a conundrum that the AI industry now has to deal with, where we're not just trying to like classify things using like an image model, which, though it did have some ethical issues and continues to, I think it's dwarfed by the scale of problems of like a large language model or a large code model, you know, because now you have these general systems which have really, really, really impressive traits, but they also have the ability to create problems. Like language can say toxic things. Code models may inadvertently introduce bugs, right? Or introduce misspecified like code, but the human doesn't realize is misspecified, and then it goes into production. So we're entering this problem of having what I think of as like high status problems. You know, the problem is no longer like, does it work or not? It's like, now it works. And it occasionally does a like really surprising thing. And so we try and focus on some of that this year, because I think those issues are just going to get larger.
So at a high level, it seems like, you know, if someone is, you know, take a human being who's very talented, can write beautiful fiction, they can also write beautiful toxic fiction.
Exactly. Yeah.
Right? So what
we
is
now have the same problems
so
of AI.
Yeah. So in the AI world, what's the general approach around to address this problem?
Well, the approach we're currently doing as a research community is to just try and get models to not generate toxic stuff. I think that this approach does not work in the long term. It's because to me, it looks a bit like training a load of humans, but there's like certain things they can say and certain things they can't say. I don't think that has worked especially well with humans if you look around us. But
there's a whole industry of people who are making a living on the so-called being canceled, right?
Yeah, but the same thing is happening with AI, where you've actually seen, you know, many actors like OpenAI and others have built sort of toxicity classifiers into their systems so that they don't generate toxic stuff. Because obviously, if you're doing a commercial service, you can't generate racial slur words, right? You know, you just can't. Or you can't generate stuff about Nazis, right? There are all of these things. But that's actually created a counter reaction where some AI researchers are trying to train so-called uncensored models as a response to this. And so
really?
Yeah, because they're like, well, I think of it as like liberals versus libertarians, right? Like, you know, a liberal, like, you know, tries to train
the intellectual dark web of the AI research community.
Yeah. IDWAI, yeah. But it makes sense, right? You know, like we now have AI systems that actually exhibit the challenges that we see in broader aspects of society. What's appropriate speech? Who gets to say what? Who gets access to what? And humans are not going to stop being human. Like we're going to now deal with these problems of different ideologies represented in different models. And I don't have solutions for you, but I have some ideas. Like, one idea is a way that we actually solved this to some extent in the case of media is we have thousands of different media publications around the world which reflect a broad range of views, and people choose among them. So it may be the case that some of these problems go away as we get more and more AI developers developing more and more of these models. Will kind of even out the landscape because there'll be a great distribution of things to choose from. But I don't think the problems are going to be entirely ones we've encountered before. Like, I think at large scale, these models have the potential to generate really harmful or dangerous things, or just crap like SEO spam at scale. And there are going to be really complex debates about what applications should you let people generate stuff for? How do you know if something has been algorithmically generated? What do you do to monitor like how it's affecting the world? And I don't think we have answers. We're as the report sort of makes clear, the AI industry has transitioned to being a full-on, industry, large amounts of capital, interesting tech, it's being deployed. But it's also bringing with it entirely new problems, which are now going to kind of gestate for a few years and then probably explode, frankly. And we now have a few years to try and get ahead of that.
And so then for companies who are looking to deploy some of these things, what are some of the guardrails?
Mostly the guard ramps come in two forms. One is having other models to stop your model doing a wrong thing. Like a nice example here is DeepMind did a language model called Gopher recently. Like all language models, the ability for Gopher to generate toxic text can increase slightly as you increase the size and complexity of the model. But along with that, Gopher gets better at classifying toxic text as well as it gets larger. So maybe companies are going to have a model and then another model which just watches that model and stops things rolling out that it classifies as being harmful or unsafe or what have you. So that's the first type of guardrail. The second type is whether you put humans in the loop of your deployment process just to sort of like check certain aspects, or to serve as sources of data that can calibrate your model about what's appropriate and what isn't. Like OpenAI had a model recently called Instruct GPT. That's a model which is trained using reinforcement learning from human feedback to be much more appropriate and better at following instructions. Models like this may actually be generally safer than models which haven't been calibrated in that way. So there would be sort of two paths. Path one is like classify and erase stuff. Path two is use humans who are interacting with your application to make the model better and more appropriate over time.
Which means for the second option, which means you will have to invest, and AI teams are terrible at this, invest in UX.
Yeah. We are actually, so again, at my day job at Anthropic, we're hiring some UX people right now because we are terrible at it. And we need to find
the reward system is not there, right? So
yeah, it's not
the reward is to beat some benchmark, not to deliver a really well thought out application, right? So
yeah, exactly.
So what I noticed that the section also calls out multimodal models.
Yes.
And that's another trend that it has accelerated in recent years, right?
Yep. In recent years, you've seen models like Clip and others emerge where you're training on both text and images jointly, which means that you can use text to generate an image, you could use image to generate text, and vice versa, and a whole load of complex things emerge here. That trend is going to yield really, really powerful systems, which will, again, exhibit really gnarly problems, actually. If I can generate an image of anything, well, you can imagine that there's a whole bunch of things people would think are inappropriate for me to generate. If I can use these models to search over images and text, maybe I can build also better search engines than the ones we have today. It's a really exciting area, and progress in it is going to be a bit slower because it's a bit more compute heavy. The way you should think about it is, once I'm doing multiple modalities, the compute budget goes up like quite significantly. That's why, for example, you haven't seen video multimodal models yet, because if I'm training on a combined, audio, video, text stream, it's really expensive. But eventually, we're going to get video models, right? But I can prime with text to generate video. That's a few years away, but imagine how crazy that's going to be when that arrives and what you'll be able to do with it.
Or what about just multimodal in the classic sense, a model that uses many different kinds of inputs?
Yeah, we're also going to get that. We're going to get, AI right now, it's amazing what language models can do, but language models and code models have just been trained on one type of data, strings of text. In a few years, you're going to have models where they have feature embeddings, which are represented by all of these different modalities that they've been trained in conjunction on. And I would expect that those models will be just much better at pretty much every task because they will have a richer representation. And a way to think about this practically is, we already know that image text models are much more resilient to things like adversarial examples or confusing images, which typical AI systems fail at classifying, because they gain robustness through this multimodality training. So a lot of the brittleness of contemporary models is going to kind of wash away as you add more modalities to them, which is, again, going to be an exciting feature.
So are there benchmarks that have much more of a constrained optimization problem? In other words, let's train a language model without contributing to global warming. you know what I mean? So
yeah.
Is there do you guys look at kind of the ecological impact?
The ecological stuff is really, really challenging, and we're starting to look into it, but we don't have great data there. And there isn't very good data here. But also, it's a bit like what we were talking about earlier. Why are there very few benchmarks for robots? Well, it's because each robot looks different. In the same way, each bit of infrastructure used to train a language model looks different. Like the infrastructure Anthropic uses is different to that which DeepMind uses, it's different to that which OpenAI uses. All of these infrastructures will have carbon, contributions somewhere in them, but all of them will be different and they'll be implemented on different clouds. So knowing how to measure this is really, really challenging. I think you can get a proxy for this by measuring just the total amount of compute that has been dumped into a model and then making some napkin estimates of what that compute costs in terms of electricity. But still, it's not very principled.
Yeah. Or do you envision a day where the people submitting a benchmark will have to explain the carbon footprint?
I think there's a chance we end up in this world, but I think that would not be a good world to end up in. And it's not because I'm against disclosing it. It's because I think it can be misleading. And I'll just give you an example. Like if I was to train a really big image recognition model and I disclose the carbon, it'll probably look like quite a bit, right? Because I've used thousands of computers to train this really big model. But if I subsequently deploy that model into production, say I'm Google and I put it into production, what if that model is 5% more efficient at image classification across all of Google's services? Well, that probably represents a massive on-net carbon saving relative to what Google was doing before. And that won't get captured by this kind of disclosure thing, partly because of all the IP and privacy concerns. And that means if we force disclosure of carbon used to train these things, I think we'll end up in this world where anytime you use a load of compute, you're the bad guy because you did a load of carbon. And you don't get to tell the story of but by doing that, I saved all of this over here. But I can't tell you that because that's a production system worth billions of dollars. So that's the challenge. Yeah.
So did you see that there was a paper in MIT a few years ago where they tracked kind of they started doing kind of forecasts in terms of some of these benchmarks, right? So if you try to lower these benchmarks significantly, then the carbon footprint gets out of control.
Yeah, I mean, I've read that paper. That paper, it's worth stating, is wrong. It's literally wrong. People have told me authors this. And what I mean by wrong is the most famous figure for that, 300,000 tons of carbon for training a language model, was them taking the largest and most inefficient way of doing neural architecture search. And also, if I remember correctly, not getting a couple of the numbers right to lead to an even larger number.
Yeah, neural architecture search is not a good thing to do with these large models.
Yeah, but basically no one does it in production.
Yeah,
exactly. It's and so it gave a very fictitious impression of carbon intensity. And I think that it just highlights how it's really hard to count carbon. And it's an interdisciplinary problem. Look, I'm involved in a working group of the OECD on AI and compute. We are covering this and we're working with people at the Global Partnership on AI, GPI, to do a report on environmental impacts of model training. But it's really, really difficult. And I'm glad the work's being done, but it's going to take teams of 50 to 100 people to even move the needle here. And until we have that level of information, I'd just be really careful of these papers that you read in the short term, because I suspect that they're just not doing things correctly because the problem is very challenging.
So how would you characterize the level of engagement of the community on the environmental dimension? Because there's a very high level of engagement on the responsible AI and ethics dimension.
Yeah. I mean, the thing is, the community is engaged on the environmental aspect pretty significantly because the environmental aspect is basically also a matter of efficiency.
It also proxy for expense.
Yeah. So basically, like everyone who works in AI is heavily incentivized to focus on this because the more I can save on compute to get the same performance, the better I'm doing in terms of research and the more efficient my system is becoming. A good illustration of this is like Instruct's GPT is 100 times smaller than GPT-3, but OpenAI wrote a nice blog post recently where it noted that Instruct's GPT was preferred by a majority of the customers of OpenAI's API. So you've made a model 100 times more efficient and now deployed it. Like that illustrates a huge efficiency gain. And so I think the community is focused on this. They just don't call it environmental impact. They just call it efficiency. And maybe there's some translation work to be done here to highlight how these are really the same thing.
So you have a section on robotics. So what are some of the highlights there?
One of the highlights here is robotic arms are now getting really, really cheap. We did a survey and you can see that the sort of price for a decent robot arm has been going lower and lower and lower in recent years. That's significant because robotics is expensive. And one of the reasons why there's not as much like benchmarks and research on it is we don't have widely used, repeatable sort of robot arms, which are cheap. We just have like really expensive industrial robot arms or like a hodgepodge of DIY systems. And so the emergence of much like cheaper robot arms and probably the emergence of more commonality among them is going to let us actually make breakthroughs here because we'll get a sense of how to do benchmarks and how to do benchmark development in this area. Also, just when something's cheaper, you do more of it. So another metric we have in the index is the cost to train ImageNet on a public cloud over time, which basically is like, how much does it cost me to train an image classifier? That's a nice generic task. Everyone does it. Well, in 2017, it cost, $1,200 or $1,300 to train a decent classifier on AWS or GCP or Azure. As of this year, it costs $5. And maybe that explains why there's tons more of this AI stuff being deployed in the world around us because it just got cheaper. So there's more of it. And so if that's starting to happen for robot arms, we can expect there to be a lot more activity in that space soon.
And with that, thank you, Jack. This has been great. I will link to the report in the episode notes. And we look forward to the 2023 edition. I'm sure you guys are already starting to think about it.
And we are. Thank you, Ben.
Yeah, thank you.